All right, class. Hello, class. Yes. Yes. No, that was pretty easy. Let's try it again. Class.
Yes.
We're going to talk about prime factorization. Let's start by going through these terms again. Okay, so everybody understands a prime number. What is a prime number? It's a number with only two factors. Okay, so 2 is a prime number because the only way you can make 2, break 1. Or I'm sorry, oh that's just a 1.
I was giving Roy my notes because he didn't finish them.
But that's not the way to do it. Plus you should be following along with your notes. So the only way you can make a prime number by multiplying is by using the number 1 and whatever number prime number you're talking about. So the only way you can make 2 is by multiplying 1 and 2. 1 times 2 is 2. You can't use any other numbers to make 2 when multiplying. That's the definition of a prime number, is if there's only 2 factors. So only 2 numbers that go into that number evenly. A composite number is like a compound in science class. Okay? A compound is made of a number of different elements. For example, water uses 2 hydrogen elements or 2 hydrogen molecules and 1 oxygen molecule. It's made from 2 different elements to make the compound water. So in math, a composite number is a number that can be made with more than 2 factors. So it might have, like the number 30, 2 times 3 times 5. All of these are prime numbers, and they make the composite number 30. Okay? There are some numbers that are neither prime nor composite. What? Some numbers that don't have 2 factors are neither prime nor composite. 0 is an example. 0 is not a prime or composite because you can only make 0 by multiplying 0 times a number. Okay? And 1 is neither prime or composite. Okay? Then, prime factorization. So, prime factorization involves finding the recipe for a number, using and finding prime numbers, the prime numbers that go into the number. And what we do in this is make a factor tree. So I use this as an example, and you can write this example down now. If you start with the number 825, and you're going to write the recipe using only prime factors, you can find those prime factors by using the divisibility rules, figuring out what numbers go into 825. We know it ends in 5, so that's a prime number that goes into it. 5 times 165 is a way of making 825. But then 165 has prime numbers in it. It has 5 in it again. So if we factor out the 5, we're left with 33. 5 times 33 is 165. 33 is also a composite number, so we have to keep going. You make 33 by multiplying 3 times 11. Now, around the outside of the factor tree, you have only prime factors. So then you can write the formula for making 825 using just these prime numbers. 5 times 5 times 3 times 11. Or, when you're writing a formula, you use the numbers in numerical order and write them out with exponents. So 3 times 5 squared, because there's 2 5s, times 11, which makes 825. Okay? Any questions on this so far? Roy?
Am I supposed to be videotaping this?
I am.
Oh.
Okay. Let's talk about greatest common factor. Greatest common factor. Let's start with these 40x squared y. I'm going to give you a different example. Look at this example. It's from number 1 on your sheet. The greatest common factor of 50 and 35. Okay? So, yeah. When you're finding the greatest common factor, you're finding the biggest factor. Doesn't have to be prime. It's whatever the biggest number is that goes into both numbers. Now, one of the ways to do this is to use the factor tree to find those factors. So, factor 50, 5 and 10, and then 5 and 2. Okay, so write that down. That's how you factor out 50. There's 2 5s and a 2 in the number 50. Or to write the prime factorization, you would write 2 times 5 squared.
Are we going to circle the numbers?
This equals the prime factorization. Okay? Lydia? Yep, we could start with 2 and 25, and then 5 and 5. And you get the same formula, exactly right. Number 35, we factor this, you get 5 and 7. Both of these are prime factors, so that's where we stop. Now it says, find the common factors in both numbers. The only common factor that are in both formulas is 1, 5. So circle those.
What about the 5 below it?
The 5 below it, there's not another 5 in this one. Okay? So we have to find the common factors in both numbers. Alex?
Oh, wait, never mind.
So, if there's only one number that's in both numbers, then that is the greatest common factor. If there's more than one, then you'd multiply those together. Okay? You'd multiply one set of the common factors. Yes? You get a question on this one? Oh. Okay. Let's go down to number 5 in your, or no, I'm sorry, number 7 on your worksheet. Number 7. Let's do a bigger one. Some bigger numbers. 315 and 360. Greatest common factor. Okay? So, what would you do first? Step 1. Factor both numbers. Yes, this is number 7 on your assignment. So, what number goes into 315? Emily, what number can go into 315? With 3? Yep. Because when you add the digits, 3 plus 1 is 4, plus 5 is 9. So we can divide it by 3, and it's 105. Good. Now, are both of these prime? No. 105 can be divided by 5, or 3 again. You like 3? What's 105 divided by 3? 33. 33 times 3. 3 times 3 is 9. Let's do 5. That's really easy. 21, isn't it? And then we can use 3, Emily. 3 and 7, yep. Now factor 360. It says in step 1, factor both numbers. Alex? Alex?
Oh, they're prime.
360 is it prime?
Oh.
We can divide it by 3, right?
130, no.
3 and 120.
Or yeah, that's what I meant.
What were you going to divide it by?
2 and 180.
2 and 180? Oh, okay. It doesn't matter where we start. We're going to get down to the same prime factors, hopefully. So 180, divide that by 20. Okay, what do you want to, what's 20? What's 180 divided by 20? How about if we did 2?
Yeah. 2 and 90, man.
2 and 90? And then what?
9 and 10.
Okay. Then what?
5 and 5. 5 and 2. It's 5.
5 and 2.
5 and 2.
5 and 5.
And 3 and 3. Okay, now, step 2, find the common factors. So whenever you can circle a factor in both numbers, that's a common factor. All right? So there's a 3 in both, there's another 3 in both. So we're going to use 2 3s. This is part of the common factor.
Wait, isn't it greatest common factor though? So are we doing 3?
Right, so we have to multiply 3 squared as part of the greatest common factor. There are 2 3s in both numbers, so we're going to use 2 3s when we're fighting the greatest common factor. There's also a 5 in both numbers. So we have to use a 5 to find our greatest common factor. Is there a 7 in both numbers?
No.
In both trees? No. Is there a 2 in both trees?
No.
That's it, isn't there? That's the common factors. So we multiply these together. 3 squared times 5 equals
45.
45 is the greatest common factor. Okay?
But
Yes?
wouldn't you do 3 to the third power because there's 4 3s?
There isn't 4 3s.
Yeah,
No, it has to be common in both factors. We use one set. Okay? It says here, we use one of the sets. There's 2 sets of these numbers, isn't there? There's 3 times 5 times 3. This is one set of these numbers, and this is one set of these numbers. We only use one set to find the greatest common factor. Don't multiply all of the numbers together. Multiply the numbers from one set.
Then why is there 2 spaces?
Why is there what?
There's 2 spots that the greatest common factors are 315 and 360.
Yep,
What are you supposed to put on yours?
the formula.
There's 2 blanks there. There's only 1 blank.
But the common factors are in both numbers. So on next to 315, you write 3 squared times 5.
Yeah,
And on 360, 3 squared times 5. And then you find one of the answers is the greatest common factor. Okay? Now, go to the practice side. on some of these, on your quiz, there are going to be some variables, like in number 7 on the practice side. I was thinking that too. I got to check on that, whether 0 is a composite or prime. I think it's neither because it's an infinite number. There's an infinite number of factors, so I don't think. I don't know for sure. I got to check on that. Number 7. Look at number 7. You've got 30m and 36n. Okay? So, when we factor 30m, the numbers that go into 30 are 5 and 6, and then 2 and 3. And the numbers that go into 36 are 6 and 6, and then 2 and 3, and 2 and 3. And then there's an M and an N. What do we do with those? Well, first, circle the common factors. There's a 2 in both. There's a 3 in both. So 2 times 3. But then M is also a number. It represents a number. And N represents a different number. So what can we do with those? Are they the same? Are there any variables that are the same in these? Nope. So then they are not part of the greatest common factor. They're not part of the greatest common factor. It's just 6. Okay, so number 7 on the practice side is 6. 6 goes into both of those numbers. But in number 8, 8 is different because it has variables that are the same in both. Look at this one. 75 x to the 3rd power, y to the 2nd power. Okay, strike 2.
Straight up, you get 1.
You got 1 the first time I went over there when I didn't have a marker.
I was just
So how are
trying
we supposed to know we had 1 strike?
Well, I don't know, you'd have to decipher that.
I was just trying to remember. And
Okay.
looking for
So, no more disruptions, please. You got 5 minutes of class left. Now, let's go on. 100 x, y. Alright, so factor both of these numbers. Write the factors for both of these numbers. Let's start with 75. 5 goes into it 15 times, or if we wanted to use 3 and 25, and then 5 and 5. Okay. But then there's also 3 x's and 2 y's that are in this number, in this whole thing. See, x to the 3rd power. So this is 3 times 5 times 5 times x times x times x times y times y. Okay, so write that out.
where do we put it?
Underneath, or on the side, next to it.
What?
Write this out. On the side of the problem. There's room.
There's so much.
And then on 100, 2 and 50,
How we cannot fit that on the side.
2 and 25.
I can't even read it.
Just write the formula. Just write this out. Okay?
What's that?
Well, we're still factoring it. Now you for sure have to start. and then an x and a y. So 2 times 2 times 5 times 5 times x, y.
Where did you get that from?
Write that on the side. Yep. Just this, right? These two things on the side, next to those, next to number 8. Okay? Now, in step 2 it says circle the common factors. So, in each one, there is a 5, and another 5, and 1x, and 1y. Okay?
I know, I didn't.
So this is due tomorrow.
What?
Stop talking. 2 minutes to go. You just couldn't keep it together. So you multiply one set of these. 5 squared times x times y, which is 25 x y.
Why didn't we get a first grade?
You're still talking. Stop talking when I'm trying to teach you how to do this. Okay? You're taking away and distracting other people. I'm not talking about you specifically. I'm talking about you as a class. When you guys start talking and you're making disruptive noises, you're robbing other people from learning. Okay? So you can't do that. When I'm trying to teach the whole class something, you can't compete against that. All right, Alex? Good. Now, multiply. Make sure you just multiply one set of numbers. Okay? Now, I want you to practice this with 1 through 11 on that practice side. And then also 13 to 23, writing down the prime factorization if it is a composite number. Okay? So it's 1 through 23 odds, and this assignment 183, 50 to 50.
Is it graded? It's graded, so it's 1 through 23
And then this is graded.
No!
Because it's always great.
Always graded.
No.
Every additional assignment is graded.